Hey children, so I'm here to help you do your homework. I'm going to help with problem 1 and problem 3, and you're going to do problem 2 and problem 4 on your own. So if we first take a look at problem 1, I need to graph this inequality, and I need to make sure that I shade the solution set. So it's important to remember that when we have an equation, the solution is an entire line, but when we have an inequality, the solution set is actually all of the points that make the equation true. So this is why we end up shading something rather than just drawing a line. But we can always start with our basic information. So this inequality is actually written in the form y greater than mx plus b. So from this, I can actually pull out these pieces of information. I know b is 7, so I know the beginning point of my line is 0, 7. And my slope is negative 1/2, which I know either means negative 1 over 2, or it can be 1 over negative 2. And depending on which way I decide to write it, this tells me how to move. Either I'm going to go down 1 and over 2, or I'm going to go up 1 and back 2 spaces. Okay, so I have all the information I need to draw my line. The only thing I need left is to determine whether or not this is going to be dashed or solid. So since this is a strictly greater than, I know that this is actually a dashed line rather than a solid line. That's because I can have all the points up to that line, but I can't actually have the points that are on that line. So I know my beginning point is 0, 7, so I'm going to put a point at 0, 7. And I know my slope is negative 1 over 2. So from 0, 7, I'm going to move down once, over to the right twice, down once, over to the right twice, down once, over to the right twice. And I can keep doing this until I feel like I have enough points so that I know the way my line looks. Especially since this is a dash line, the more points I draw, the easier it's going to be for me to draw an accurate line. Now that I have all my points, I draw my dashes. I have a dashed line. Again, I'm not done because I need to shade the points that make this inequality true, which means I have to check the points. Okay? Now I have to check either a point that's on this side of the line or a point that is on this side of the line. Now it doesn't matter which point I check. I know generally we check 0, 0, but I can really choose any point that I want. Okay? So for example, I could choose this point right here. This point right here is 2, 4. So that's the point I'm going to check to see if it works. So if I take a look at my inequality, okay, I have y equals, or y is greater than negative 1/2 x. The x in my point was 2 plus 7. And the y in my point was actually 4. So I want to know if this ends up being true. Okay? I want to know if 4 is greater than negative 1/2 times 2 plus 7. Well, negative half of 2 is negative 1 plus 7. Negative 1 plus 7 is 6. Is 4 greater than 6? No, it's not, which means this is false. So that means I know this point, this side of my inequality is actually the false side. So the other side must be true, so I would shade the other side of this inequality. And there we go, that problem's done. I also said I would work on problem 3, so we're going to come down here and take a look at problem 3 together. So I have y is less than or equal to negative 2x minus 1. Again, this is also an mx plus b form, which makes pulling out the information I need to graph this inequality a lot easier, because I can recognize that b is negative 1, which means the beginning point of my graph is 0, negative 1. And I can also recognize that my slope here is -2. And as we always say, every number is a fraction in disguise. So I know this is -2/1, which tells me that my slope is, my line is moving by going down 2/1. I use these two pieces of information to draw my line, except I need one more piece of information, which comes from this sign here. So from this sign, I know that this line is actually going to be solid, not dashed. This means I can have the values on the line as well as the ones that are going to be on either side of the line. So I'm going to start at the point 0, -1. And I'm going to go down 2 spaces over 1, down 2 spaces over 1 until I feel like I have enough points to draw my accurate line. Down 2 spaces over 1, down 2 spaces over 1, down 2 spaces over 1. I can also go up 2 spaces and back 1. We could always do the opposite. Again, just until I have enough points that I feel like I can draw my line. Then I'm going to draw my straight line. Mine's not as straight. Y'all know why. And then I'm not done because I need to shade the side of the line where the points are that make the inequality true. In order to do this, I check a point. So again, we can check any point we want. Just to make this simple, I'm going to go ahead and check the easiest point right here, which is 0, 0. So that is right here. And to check 0, 0, I would plug in 0 for x and 0 for y. So I have 0 less than or equal to -2 times 0 minus 1. I know -2 times 0 is 0, so this becomes 0 less than or equal to 0 minus 1, which becomes 0 less than or equal to -1. Okay, 0 is actually not less than -1. 0 is actually greater than -1, so I know this is a false statement, which means that that side of my inequality is actually the false side. So if I look at this point, 0, 0, that's the point I checked. This was false, which means the other side of my inequality is actually the true side. So that's the side that I want to shade in, because that's where all of my solutions live. Okay, go ahead, use these two examples to do problems 2 and 4 on your own, and I'll see you tomorrow.